So my presentation today will be about SWAN. SWAN is a CERN service for web-based data analysis. There was a presentation already last year in Zurich about the early stages of the service. So today I will give you a summary of what we've done during this year and how SWAN has become this CERN service that integrates that federates other CERN services and technologies. Before going into the details of the service, I will do a first introduction to the notebook technology for those that are not familiar with it. So notebooks are the interface of the SWAN service, and they are this web-based interactive computing interface and platform where you can combine in the same document different types of information, code, equations, text, visualizations, all in the same document. And another good thing about notebooks is that you can use a thin client like this with your browser and open the notebooks. Okay? You don't need any local installation if a server provides you with this notebook interface. Let's see an example of a notebook. This is actually how a notebook looks like. So immediately you can see how we can find in a notebook, we can find text. You can format it with Markdown. You see a title, explanations. Also importantly, you can find code. In the space that you see here, where code is, this is called a code cell. In this case, it's a Python code cell. Notebooks are not restricted to any particular language. They can accommodate different languages. There are several of them supported. This is Python. And then when you type code in a notebook, in the end what you do is you run that code. And as a result of running that code, you see in the same notebook appearing in the output of the cell, it can be some text, but in this case you see how it's some graphics, some plot that we obtained from the previous code. Okay? So you see how in the same document you can embed, you can combine all these different types of information. So at CERN, in particular in the EP SFT group, we use this software called Root for data analysis. It's widely adopted in high energy physics. And we thought that the notebook interface, this interactive analysis interface, was very good for our software, and we integrated it with it. So in particular, what we offer to the user is the users can write their notebooks in C++ with Root, and they can also write them in Python. And the graphics that they can obtain in the notebook can be not only static images, but also interactive JavaScript visualizations. So we really went further, and after integrating Root with this notebook interface, we developed a full-blown service that provides users with access to these technologies. And this is actually SWAN. So SWAN has an interface that Jupyter Notebooks is a service that provides you with notebooks on demand, let's say. And the idea here is that only with your web browser you connect to a server and you do your data analysis. You can do platform-independent data analysis with Root. In our case, although SWAN is not restricted to any particular analysis ecosystem, let's say, so you can use others, like all the Python libraries are, you name it. But the idea here is that everything that you do when you have your browser, you have your notebook, you type your code, and you want to run it, this does not run in your machine, but it runs on the server. All the calculations are on the cloud side. Also, the input data and the output data are there for you to use. Then the sharing part of it. So notebooks are for sharing, because when you write a notebook, you do it because you want to tell a story. You want to tell others what you did. You want to show others what you did. And you put all together, all this information in the form of a notebook. So the sharing is a very important part. Later I will give more details, but it's a very important part of the SWAN service. And for this, storage is key. Another use case of the notebooks, which is very useful, is teaching, education. As in Root, in our department, we already use SWAN and the notebooks as a tool for giving exercises to our students, for organizing tutorials, and we believe it's it's very, very useful. I will show also examples of that. So in this slide, you see the building blocks of SWAN summarized. So first we have storage, of course. As storage technologies, we use EOS for mass storage, and we also use CernBox. So when you are in SWAN, you have available these two. You have available your user files in CernBox, and you can access them with your credentials, and you have EOS as well. Regarding software, where is the software in SWAN, where it comes from? At CERN, we also have this distributed file system, which is called CBMFS. And in CBMFS and in SWAN, users can configure their software environment to pick packages from CBMFS. So this is let's say, the central distribution of software in SWAN comes from CBMFS. And finally, we have infrastructure, so where we allocate user sessions. So for that, we can leverage the OpenStack infrastructure at CERN, and in particular, we also use Docker to encapsulate user sessions. When you log into SWAN, you will be allocated a session, and this session will be isolated from the rest inside a container, where you will be able to run your notebooks. So most of these technologies that I just mentioned, they belong to the CERN ecosystem. I said before that SWAN is this federator of services that already existed at CERN, and this is true. If you see the example, CBMFS for software, CernBox EOS, the virtual machines at the cloud of CERN, the authentication with CERN username and password, all these are components that already existed and that we put together to bring some added value to the users. Of course, we also use a couple of external technologies. We use Jupyter and Jupyter Hub and Docker for the user sessions. And you can see all these technologies combined here in this picture. So I'm a user. I connect to SWAN with my browser. I authenticate, in this case, with my CERN username and password. And then once I have authenticated, I'm granted a session. And this session is encapsulated by a container. And from inside this container, I have access to the software with CBMFS, and I have access to my data also with CernBox and EOS. So this is more or less the global picture of it. And then once you log into SWAN, the first thing that you see after you have authenticated is your CernBox. So CernBox is your home directory. In this case, this is the content of my CernBox. And if you went to the CernBox web interface, you would see exactly the same content. And we believe that having people logging into SWAN and directly using their CernBox, writing their notebooks there, generating the output data there, also the input data taken from there, is more convenient when you compare this service to other models like other services that also offer notebooks on demand, but these services are volatile in the sense that they provide user sessions where users can write notebooks, but then when the session stops, you lose all your data unless you download it explicitly to your computer. So we believe that this model where you log in, you do your work stays there, you can close your session, you come back, the files are still there, is more adequate. It's more adequate, but also it's more challenging because in the case of the notebooks, it's a very interactive interface. So people really expect that they can do fast operations like I open a new notebook, I create a new one, I type my code, I get the results, I generate some output data in my storage. So all of these are operations that they do very frequently, also saving notebooks, and they expect these operations to be fast. So that's why it's also challenging. Then about synchronization and sharing in SWAN with CernBox. So you as a SWAN user, you can go into SWAN and work only with SWAN. So you create your notebooks there, you write them, you have your input data there, the output data is also there, and that's perfectly fine. You only work with your web browser, you connect to the server, and everything happens, let's say, on the cloud side. But another option that SWAN users have is that they can also choose to install in their local machine the Sandbox synchronization client. And then what they can do, of course, is they can produce notebooks and data in the cloud, and this content will be synchronized automatically to their local machine, because maybe they want to work with it locally, inspect it locally. And the other way around, if they produce some content locally, this will also be seen by SWAN. So this is about synchronization and sharing, and also sharing is a very important part. I produce a notebook, and like I said, when I write a notebook, it's because I want to tell a story to someone, so I want to share it with others. I want others to see it. So using Sandbox as well, you can share your notebooks with other users, and these users can inspect them and maybe modify them and maybe reshare it with others. A few words now about sharing of notebooks. So notebooks are a particular kind of file, and there are some things that have to be taken into account. In Sandbox and in SWAN, we allow sharing of notebooks first in read-only mode. So you can share a notebook with some other person, and this person can see a static visualization of the notebook, which is an HTML page that shows you the content of the notebook, but you cannot go inside and modify a cell and write some code and run it. It's all static. So this is one option. The other option that is supported now is that with Sandbox you share by link in read-write mode. And, but with this you have to take care, because currently Jupyter does not support concurrent edition of notebooks. So it's not, in this sense, it's not like a Google document where several people can at the same time modify different parts of it. So this is something that is on the roadmap of the Jupyter project, to allow concurrent editing, to allow one person working on one cell, another person working on another cell, but it's not yet supported. And another consideration, important one about notebooks, is that often notebooks by themselves, they are useless in the sense that they often rely on some input data to run, because in the end, in a notebook, you have code. Right? So often, it makes more sense not to share individual notebooks, but to share directories, where you can have several notebooks and all the data that these notebooks need to run. Another way of sharing notebooks that we use is these galleries, public galleries, where this is an example of the SWAN website, where you can find these galleries that are divided in different categories, and then people come there and they see snapshots of the notebooks, screenshots, sorry, and they can either choose to open them and visualize them statically, or also if you have a look at this small ribbon on the corner, they can click there, and if they authenticate with a certain username and password in SWAN, automatically SWAN will open this notebook in their Sandbox. It will copy the notebook to the Sandbox and open it for them to inspect it and also to run it in their account. Then about software, also storage plays a role in configuring software environment. So like I mentioned before, when you are in SWAN, your environment is configured with CVMFS. And in particular, in CVMFS, there are these so-called LCG releases, which are sets of packages that are distributed together. And what users do is they configure their environment to use a particular LCG release. And then all the packages that are included in that release are available in SWAN, in the SWAN session. We do this because we have this centrally distributed software in CVMFS, and we don't rely on Docker for distributing software. We have a thin image that contains nothing but the Jupyter server itself. And then for the rest of the software, we rely on something that we already have at CERN, which is CVMFS. Then if there is a user that has some software, some library, that is not on CVMFS because it's not mainstream or because it's a custom library, this user still has the possibility to install it in Sandbox and then configure the environment to pick it from Sandbox. So we give some flexibility on that regard as well. Another use case, I think interesting use case of SWAN is offloading computations to external resources. So by default, when you log into SWAN, you are allocated a session, and this session is inside a container, and this container is allocated some resources. And you are limited to the resources of that container. Whatever you run will be limited to those resources. But if you want to run something bigger, which in our case could be some physics analysis that takes a long time, maybe scientists, they want to contact external resources and offload computations to those resources. And only when they have the result of those computations, they can inspect them back in the notebook interface. And currently we are investigating this setup, which is from a container in SWAN, from your notebook, you launch Spark jobs. Spark is a distributed framework for data processing. And you basically submit your job to a master that then will distribute the tasks on a set of workers. Of course, storage also plays a role here because you will have EOS there, so you can take the data that is available on EOS with your credentials, and also you can take the software from CBMFS. Now, to give you some statistics about these first 6 months of operation of SWAN, so we released this pilot service end of 2016. And then first it was only open inside CERN, then we opened it also outside, I think end of August, September, something like that. So now anyone with a CERN account can use it. Also a CERNbox account is required because CERNbox is your home there. We've had more than 4,000 sessions already created since then. Twice as many opened, because in a session you can open as many notebooks as you want. And normally we have these peaks of more than 200 sessions opened when we use SWAN for tutorials for education, because you have all the students coming at the same time trying to create their sessions, and then the load goes up suddenly. The users, they come mainly from Europe. So CERN users that are located in France, Switzerland, also other parts of Europe. But now we are also starting to see people coming from other parts, from other labs, physics labs from other parts of the world, the United States, South America, also in Japan, even Australia we saw some people connecting. So we are kind of expanding our user base. And I wanted to just to discuss a couple of examples of SWAN use cases, SWAN users that we know. This is an example of a physics analysis. It's from a colleague of us from one of the CERN experiments, LHCb. He's using root in this notebook to do a complex fit. He reads data from EOS in SWAN, and he basically creates a notebook to document and inspect all these results. And these results were actually published in a paper. This is an example of physics, but we also have people with different needs and that use different tools. And this is an example of the BEAMS department at CERN. In this case, they don't use root. They use other libraries like Python ecosystem, SciPy, Matplotlib for plotting. And these people, what they do is they monitor the status of the Large Hadron Collider, and they from their notebooks, they query databases, and they plot live data about the status of the collider. Okay? And this is one example from one of our colleagues. So you see these two examples, one that is more physics related, that uses root, and another one that uses a different set of libraries with a different goal. Then for outreach, we had this case of a colleague of us working with CMS that used SWAN and the notebook interface to produce these course about experimental high energy physics for high school teachers. It's actually in Finnish, all of it. It's available in the SWAN website. But this is an example of how this platform can be really used for education. And we actually, ourselves, we use it a lot. So since the service is up, we have done several tutorials with it. The most recent one, and perhaps the most intensive, it was a 4-day practical statistics for particle physics analysis. It was a course of 4 days, and then we had this peak of 250. We have also used it for teaching root to our summer students. We have also used it in the CERN School of Computing for lectures about parallelization, for exercises about parallelization from a notebook. Data science, machine learning workshops. So we really see how this is a powerful tool for this kind of scenarios. So I will just go now to the summary of my presentation. We have at CERN this SWAN pilot service already available. It acts as an integrator, a federator of other services that already existed, but they brings them together, and it gives, I believe, an added value to our scientists. So examples of these technologies that are there, CERNbox and EOS for storage and CBMFS for software distribution. As future plans, now there is only one instance of SWAN running at CERN, but there is already someone working on packaging SWAN, so making it easier for people to replicate instances of this service in other places. Then we are always trying to improve the experience that users have with sharing. Also the number of packages that are available in CBMFS. Recently we added a lot of machine learning libraries. So CBMFS is nothing static. It's not a static body. We continuously improve it. And finally this exploration that we are doing about using external resources, not only Spark clusters, but it could be batch systems, physicist that sends a job to batch, and then when it's done, it can inspect the results in the notebooks. And this is all from my side. Thank you for your attention.
Thank you very much. Questions? Yes, Paul.
You mentioned the results being published. Have you thought about DOI referencing?
No, but if you are interested, I can ask for it. Yeah. But
I'm just curious if you
yeah.
thought about mechanism for preservation.
Yeah. So preservation is, let's say, a complicated matter, because it is true that with a notebook you can have, you can see there the code that you run, and you can distribute it together with the results. So it's a step towards preservation. But then there is other things like the software that you used in order to run that notebook at that time. This has to be somewhere, and this is not included now in the metadata of notebooks. For instance, there is no metadata about that. So notebooks by themselves, they can help in preserving results, but they are not the ultimate solution to that.
Kuba.
I mean, if this link is done, then it becomes easier to bring together all these parts. It's true that the pieces are there, but they have to be together in some system. Yeah. Yep. Mhm.
So just for information for people who are not familiar with what the nodo is, this is this little reference at the second page of the book of abstract. Okay, so if you really want to know what it is, it's there. Okay. No more questions? No. Thank you very much.
Thank you.